So last Thursday in class, we talked about the potential for having some snow on Friday into Saturday. And I remember very specifically showing you a lot of information available to me on the web that gave us a pretty good predictor of about 1 inch of snow in Champaign-Urbana. And as you all woke up and found out on Saturday morning, we had 9 inches of snow instead. And the picture in the background here is actually my house. And you can see that the roof clearly had about 6 or 7 inches piled up, and we got an additional 2 inches throughout the day. So, even though the Hydrologic Prediction Center said that there was only a 10% chance of us seeing at least 4 inches of snow, and the models that I ran for you that day said only an inch of snow, why in the world did we get this forecast so wrong? Well, it turns out we didn't necessarily get the forecast wrong, we just got the location of the forecast wrong. I mentioned in class that you'd have better chances of seeing snow the further north you went, and all the model predictions said about the exact same thing. So the goal is to kind of figure out what went wrong. So let's first of all take a look at what actually happened. First of all, let's start off with kind of an animation that's going to show you where the low pressure system tracked. And so you're looking here on Friday, this is about Friday around noon on December 3rd. And we're going to watch the position of a low pressure center that's initially going to start out here just on the eastern side of the Rocky Mountains and work its way to the east. So here it goes. It dips a little bit further to the south, comes across parts of Oklahoma, and then builds as it goes across southern Illinois. Now we know what to expect when a low pressure system goes to our south, right? That means we have our heaviest snows on the back side of the system, in other words, back here to its north. So automatically things are looking good. At least we know that we're supposed to get snow out of the system because it's winter and extratropical system tracked to our south. But what was interesting was where the heavy snow band set up. Most of the models indicated that along Interstate 80, just to the south of Interstate 80, was where the most snow was going to fall from the system. And instead, it was along Interstate 74, which is a little bit further to its south. So why did Interstate 74 get hit worse than anything else is what we want to take a look at. First, this is what the snow actually looked like as it spread across north, kind of east central Illinois. Watch us start all over again here. There comes that heavy snow band right through here. And Champaign is just on the edge of it right there. So why did the snow fall here, and why did it fall so great across Champaign than any other location? Well, let's step back and take a look at the radar data from this day. This is what the snow band looked like as it just came across central. Now, Champaign is right where I've placed the cursor, and here's the heaviest snow band coming right across parts of Peoria, heading toward Bloomington. Here is the snow band from that system as it dips to the south and starts to curl across the southern part of Illinois. So the goal of a meteorologist when we do winter weather forecasting is to find where the leading edge of this band of heavy snow is going to set up first. Because if you find that leading edge, you're going to find your target zone for where your heavy snow is going to be. All day long, the air across central part of Illinois was incredibly dry, but wherever that leading edge of that snow gets to first, well, that's where your snow is going to start to fall. It's first going to fall as virga and evaporate. And that evaporation process starts to moisten up the lower levels of the atmosphere. So what I noticed was this: as this system moved across, that heavy snow band, well, it ended up eventually tracking right across Champaign. Right about now is when it was really snowing heavy across Champaign. Notice on either side of that snow band, it wasn't snowing nearly as hard as this, but right in through here, we have radar reflectivity values that are 35 to 40 dBz. When you have that intense of a radar reflectivity, when it's snowing, the amount of snow that falls can be 1, 2, maybe even 3 inches an hour. And what happened is it just continued to snow right over the top of us, that one skinny little narrow band for much of the night. And instead of giving 1 inch like they got on either side of the band, 1 to 3 inches on either side of the band, we got 6, 7, 8, and even 9 inches in some locations. So there the band goes. Now, as the Saturday morning kind of time period gets in here, we continue to get some flurries, we tend to get some light snow, and that added an additional 1 to 2 inches of the whole thing. But to really see what happened, let's zoom in on what was going on right over Champaign. So here we go. System started snowing over us. When you look at these radar reflectivity values, we're seeing stuff in the 20s and the 30s. But then watch as this one distinct heavy band right here sets up across Champaign. Notice how narrow and skinny it is. In fact, it fits all the way inside of our county. Either side of it, no snow. In fact, you can even see by this big donut hole in the radar image here that the air must have been incredibly dry to our west and south. But right across us, we had radar reflectivity values approaching 40. When they get that high, that's a snow rate of around 2 inches an hour. And this one narrow band sat right across us for much of the night. And there it is. Now, this is what happened to bring us that heavy snow. But to take this a step further, especially for my 201 students, I want to show you what really made all of this happen. So there's my house again. How did we get those 9 inches? Because when you look back actually at the actual numbers, let me find it here on the web, this is what actually fell. So try it again. Here's what actually fell. Here is the National Weather Service's observation station down at the Illinois State Water Survey. We got 7.7 inches on Friday night, an additional 1.1 on Saturday, for kind of a grand total so far this month of 8.9 inches. In fact, here is the map made by the National Weather Service that shows the one little band as it stretched across, basically from Peoria down through Bloomington and on over to Champaign, where we got that heavy 6, 7, 8, 9 inches of snow. Notice on either side of it, there's the 2-inch margin. On either side of it, there just wasn't much, but right along that narrow band, we got it. What made that narrow band? Well, 201 students, here's a direct application of what you just learned. So, this is a map. This map is made to 850 millibars, which is about a mile above the surface. What is color-coded on this map is a variable I haven't taught you about yet, but it's called the equivalent potential temperature. When you look at this, just understand that the higher the value, or the more red the color, the more warm the color, that means there's more moisture and more heat in that air. And the darker the color, the drier and the colder. Now, if we want to find where the heaviest band of snow is going to set up, we simply need to look for the axis of dilatation, right? So what I notice is this: there was strong warm air advection out of the states like Texas, Oklahoma, and Kansas across Missouri, and that warm advection took a split right here. Some air turning north, some air turning back to the south and east. From the north and east side, we had wind that came in just like this and did the same sort of splitting. What we learned is this: the axis of contraction runs along this line right through here. The axis of dilatation is through here. And what we learned is the heaviest snow bands set up along the axis of dilatation, where you have your strongest deformation and you have your strongest frontogenesis. This is basically where you're tightening up your temperature gradient the greatest. That increases your vertical motions, and that is where you're going to get your heaviest snow band. What made this such a difficult forecast was finding where that frontogenesis was going to occur, and all the model predictions up until just hours before the system started said that the heaviest snow was going to fall just a little bit to the north and east of where it did, which is why the forecast for 1 to 3 inches for Champaign seemed valid. But as soon as the forecast evolved, a winter weather advisory went out, and on top of that, then a winter storm warning came out for everywhere inside of this deformation zone where you had your strongest frontogenesis. The end result was we got 8 to 9 inches rather than 1 to 3. It is difficult to do winter weather forecasting because if you look at how narrow that band is, and you're going to rely on a computer model to predict where that narrow band is 3, 4, 5 days in advance, well, that's a very, very difficult thing for anyone to know. But the end result is we have a beautiful landscape outside right now. My daughter woke up, ran outside, and started yelling, "White outside, white outside." That was before she fell face first into the snow, and ever since then has hated it. So, interesting early system so far this year, and it's already got us well on our way to having a very, very snowy La Nina winter here in Illinois.